Hey guys, welcome to the third and final video of Learning from Gliders, hosted by the Learning Farm and by me, Daewon. So the third lesson is a glide ratio lab. Like I mentioned in my previous video, this is going to be a much shorter video, but it is going to be more of my handoff to you, for you to go and explore a bit more about this on your own. So to begin, there is a value about our glider called the glide ratio. So what is the glide ratio? It's also called the glide slope ratio, but it's a number that indicates how far a glider travels this way, horizontally, versus how high it was dropped from. So if you see the picture that I have on the right there, that silhouette is supposed to be me. Me being 6 feet tall, when I fly the glider, it's going to be about from a 5-foot height. So that's why we have our tape measure. You can measure how high you are and from how high of a height you drop it from. And then when you push to be able to release your glider, how far does it go? And try to measure it. If you haven't learned divisions yet, you can use your calculator to do the horizontal distance, or how far it went, and divide it by from how high you dropped. Make sure you're using the same units. As in, if you're going to say, I dropped from 100 centimeters, don't measure the distance in inches and then expect to get this the correct ratio. Make sure you're using the same units. So what kind of ratios are we expecting? Well, maybe we can look at some examples. A sugar glider has about a glide ratio of 1.8. So what does that mean? That means if a sugar glider starts gliding from a tree that is 1.8 meters high, 1 meter high, it's going to glide for about 1.8 meters. The space shuttle, when it was coming back from low Earth orbit into the Earth atmosphere, it had about a 4.5, which means for every kilometer that it dropped, it went horizontally, traveled horizontally 4.5 kilometers. In the same way, paragliders have a pretty high glide ratio of 11, and hang gliders have even greater, 15. For aircrafts, most jetliners, including the 777X and the 787, it's difficult to measure exactly what glide ratio they have, but in general, they have about 15 to 18. So what does that mean? 787 is flying, and then suddenly, it loses both of its engines. So it needs to glide to the nearest airport. If it happens to be 10,000 feet in the air, which would be pretty low, but if it's 10,000 feet in the air, with a glide slope of 15, it'll be able to go 15,000 feet horizontal. So a pilot would be able to calculate from his altitude and how fast he is going to be able to know, okay, I can reach a destination this far away. For high performance gliders or sailplanes, just like the DG-1000, they can actually get really, really high, 60 to 70 in fact. I believe the world record is almost about 80, but you can look that up yourself for sailplanes. So now it's your turn. Go ahead and measure the glide slope of your glider. Make sure to put the wing all the way back. Remember, you want the center of lift and center of mass to be on top of each other. Make sure your horizontal and vertical stabilizer are in place and it's balanced this way. And release. Now, when you're running experiments, make sure to follow a few simple key guidelines. Be consistent. Be consistent as in be flying from generally the same place. So if you're flying indoors, from your kitchen maybe into or your bedroom, make sure to try and be as consistent as possible because these guys are very susceptible to drafts and different types of winds, even things like windows that are open. I know it's summer right now, but maybe close all the windows in order to do it. 2 is record your results. Have a notebook, have a piece of paper. Record every single measurement that you take. And then measure multiple times, which is a third key guideline. So it's going to be a little bit different every time you release it. But try to release it in the exact same manner. I like to release it from above my shoulder in the exact same way like this, right? So try to be consistent about how you're doing it and measure multiple times, and you'll hopefully get similar results. And even if they're not exactly the right results, which most likely they won't be, you can average them out. And then eliminate variables, which is a 4th key guideline. And you can do this again by closing windows, right? Removing obstacles from your surrounding area. Try to get as consistent of experiments as possible. And number 5, be creative. So you'll probably be able to find the glide slope of this glider. You will most likely get a result between 7 and 9, which means if you drop this from a meter height, you should be able to let it glide for 7 to 9 meters. That's about what you'll get. Yours is going to be a little bit different depending on how you fly it, where you fly it, and just the state of your glider. But there are additional things that you can try. So for example, I put just, I don't know, off the top of my head, additional experiments that you can try. What about without the horizontal stabilizer? Remember, horizontal stabilizer, though little, creates a bit of lift. Well, we can see just how much lift by trying the experiment without it. What about extending the wing? So you can do this by adding additional cardboard paper to the side of it. I don't have a good example, but just think about the fact that the wing gets longer, which would generate more lift. However, it's now added more weight. So the effect of gravity is stronger. What's going to happen? Does that increase our glide slope? Maybe. Added nose weight, just in the same way that we added quarters in our last video, you can add additional weight here. You can even add additional weight to the tail, wherever, right? I brought this up in the first lecture, but our wings are anhedral, dihedral. They are angled upwards. What happens if you flip them upside down? Does it make a difference? Who knows? Compared to different types of paper airplanes that you create. I know you've created many different paper airplanes, whether from your homework or scrap pieces of paper that are lying around. This is a really good time to be able to test the performance of them. What type of glide slope ratio do they have? Can you make one that's better than your glider? Now, that's pretty much it for all of our lectures. Like I said, this is my handoff to you. I want you to be able to explore additional topics and more about gliders and aerospace and aerodynamics in general. So these are some additional resources. I know this is a video, so you can't click the URL, but you can mostly Google these. The first one is a NASA Let It Glide guide PDF. And it's just a lab that NASA, I think Glenn Laboratory created on the principle of gliding, and it's very similar to the lectures that we have, but it just adds a bit more pictures and some additional information. Another addition is NASA has a whole guide of students K through 4. They're filled with stories to basic aerodynamics, and if you just Google it, you'll be able to find it, but it's a really great resource to better understand what happens. And NASA guidelines are not just for airplanes and not just for gliders. There's for spacecrafts as well as even some, underwater vehicles as well. So that's a really great place to look and explore. The third one is an AMA flight school. This is a bit more advanced. but I think the pictures and the analogies that they use are really solid. It's a great place to learn some basic aerodynamics, and if you paid attention in the first two videos, you'll be able to pick up a lot of the things. And the fourth one is for much older students, for how things fly. They're going to add to the terminology that I've already added. Let's see, some challenge questions that I brought up, things such as stall, creation of lift. Let's see, anhedral versus dihedral. These are actually topics that will be covered in howthingsfly.si.edu. So feel free to look on those resources as well. And lastly, thank you guys so much for watching. I know the videos were pretty long, and it's actually chock full of information and terminology you may have never heard of. But again, I hope that it sparked a bit of creativity in you. And yeah, you can receive a glider as a kid. You can fly it around for like 2 minutes and just be done with it. But there's so much more you can actually learn from it. So I hope these videos helped. I've attached my email down below. It's ddkdaewoon@gmail.com. That's my personal email. And if you have any questions, or found the videos useful or helpful, or you learned a bit more, or if you have general questions about the video themselves as well, feel free to contact me at that email. So thank you guys again so much. Shout out to Krista for giving myself and my wife Anna an opportunity to do these videos. She's really wonderful, and Learning Farm is really wonderful, and we miss it a lot. So yeah, these videos are really great for me, and I hope they were great for you guys too. So bye.